So you guys can hear me, right? Yeah. So do you guys know what this is? It's a camera, right? It's not only a camera, it's a shock-proof and water-resistant camera. But it's also a weapon against prejudice. What is a prejudice? Do you know that? It's categorizing or classifying something without having sufficient information about that. That's a bullshitty definition I made up. So you all have prejudice, I know it. And I tell you what, it is pretty, I love you. Did you step into that channel thing, maybe? So
just so you know, I'm on stage all day.
So let's get back to the prejudice thing. So it's pretty natural to categorize or filter out information. So our brain is designed to analyze things or humans and look for marks, for specific indicators, and then it will assign judgments to that. And without knowing too much about a person, for example, you judge that person. So our brain is designed to filter out information and store it abstract in your brain. So for example, while you watch me walking around here, your brain tells you there's people right of you, there's people left of you, but if I ask you, who's right next to you? It might be your mother, but your brain just tells you it's nerds. So, so this is because the brain filters out and abstracts information. Let's make an example. You knew there is going to be Germans at this conference, and I know you guys were like, okay, it's going to be a fetish, sunburned guy, beer belly, maybe wearing lederhosen, and of course sandals with white socks. Do we have any Germans in the audience? I think maybe Konstantin. I mean, he's not here, but if you see him, check out his feet. He's wearing sandals, but he's not wearing white socks, which proves that prejudice and you were wrong. The same, we can put it the other way. So I was living in Munich for like a half year, and I went out with friends. It was a beautiful summer night, and the wind was in my hair, and I was wearing like flip-flops, or thongs as you call it, and short pants, and I think this very shirt, and my friends were like, ah, cool, don't you want to wear something warm? And I was like, well, why? I mean, it's a warm, beautiful, mild night, the wind is in my hair, so it's going to be hot, so why should I wear shoes? And I was, oh, it's okay, just go, but we'll treat you as our exchange student from Australia. I was like, okay. And the funny thing is, we went to a bar, and not that I had problems getting into that bar with thongs. Also, like 2 or 3 people, I can't remember because I was drunk, came up to me, started the conversation in English. And I was like, what the fuck, in German? And it turned out those guys thought I'm from Australia. So this camera, if you see it pointing towards you, if you see me taking pictures, is not to use those pictures all over the world in Ruby conferences. No. It is to bring the truth back to Europe. It is to fight prejudice. All right? So I want you guys to take a look at this picture. Oops. It is a train. It is terribly loaded with people. By the way, this picture was taken in Australia. It's going from Melbourne to Perth. And so I think that the reason for this train is served. I mean, the train takes people from point A to point B, which is OK. It might be a little bit slow, because there's a lot of people. On the other hand, the air condition might be great for those guys sitting outside. If there is any problem, the train has to stop. The maintenance guys will have problems getting to the problem in the train, because they have to fight through all the people, so this might be a problem. Also, if there is a kangaroo on the track, this guy in the front might break his leg, not so cool. Whatever. This is the first coding slide. Are you ready for that? What has this class to do with this train? I don't have a clue. Whatever, but here's an example. Let's say we have an active record base class, and we do different stuff in it, and we also have this after save hook to send out SMS notifications after I saved this very record, okay? So you guys all did that. Everyone is looking at the floor right now. So I use this API, I use this record in my controller. So I call save, and the controller, or the model, will send out SMS notification to that user, hey, you were saved, or whatever, which is exactly what we want. I also use the same API in my migration. So I'm changing that user record, and I'm calling save. And I'm feeling super smart about that, because I'm reusing the API, which is awesome. Reusability. And so I'm eager to hit enter. I run the migration, and what happens? Of course, I send out SMS notifications to 500,000 users that they were saved, which was not my intention. So the cool thing about Rails is it provides us all those tools like testing and, I don't know, sprockets and asset pipeline and active record and best practices. A lot of those best practices are not so best practice, whatever. But as soon as the project gets complex, we're getting into trouble with what Rails gives us. Like we end up with huge controllers. Please note the elephant. Huge models and fat views. This is Google image search. I did another search and ended up with this fat views. And so I'm not giving this talk to hate Rails or something, like to hit on Rails. Because there's two possibilities. Either we say, fuck Rails, I'm using whatever, Sinatra, or we get along with Rails and we use appropriate tools to change that default behavior. And this is what this talk is going to be. And so let's say this train is our active record base class. I know it's a stupid analogy. And every person on this train every person on this train is a feature, like logging, I don't know, saving notifications, whatever. So here we go back to this class, and now it makes sense, right? Tumbleweed. And what if we would change our class from this one monolithic train to this approach? What if we had millions, hundreds, dozens of independent units encapsulated, working autonomously, like this bicycle rider. So if there is a problem on the street, the bicycles can go different ways and take shortcuts. And we don't have the problem of I don't know, hitting cows or kangaroos, because bicycle is way too slow. But what I want to say is, if you have complexity like this train, and you cannot manage this complexity anymore, you have to reduce the complexity. And this usually works by applying object-oriented techniques. So applying object-oriented patterns to Rails is something that is coming up the last year. So we have to choose between one monolithic active record or the cool bicycle riders with dozens of independent classes. The problem is most of the people suffer from a sickness I invented, fear of the class. So do you know this guy? He's from the Rails core team. He's awesome. And so the patterns I'm going to show you are to take away that fear of using more classes and more instances in your applications. I start with checking out some patterns for the model layer. So the thing I want to do is split my domain, my business logic, from the persistence. And as an example, I use the scenario of two cowboys sitting at a campfire. Do you have cowboys in Australia, by the way? How are they called? Jack what? Jack Wolfskin? No.
Jackaways.
Okay, so whatever they are called, we got two of them. One is called Jim, one is called Steve. And all I want to model in my application is this chat. Two cowboys exchanging messages, all right? And in order to do that, I'll use PORO, the PORO pattern. Not porno, PORO. PORO stands for plain old Ruby object. And here's how this application is supposed to work. So I instantiate two cowboys. Then I call the same method on Jim, passing in the message. And then Steve can respond by calling the respond method. And I pass in the response content and the question object so that we can model this conversation. So this is all we want to achieve. And I start with creating the Cowboy class, because we need some kind of starting point. And instead of using active record and stuff, and instead of thinking about tables and database relations, I know you guys are already, OK, Cowboy table, link to has many messages, and I'm just thinking in plain old Ruby objects. So I use OpenStruct. Do you guys know OpenStruct? I think we saw it a couple of times in the last brilliant talks. And what I do is I instantiate the Jim, like a Jim Cowboy, and OpenStruct will automatically provide accessors for the properties. This guy is leaving. So to model that first step of the conversation, I just have to implement the same method on the Cowboy class, which is pretty simple. It just receives the content, instantiates a message object. I decide to encapsulate that message in a message object, which is simply passed on a chat array, nothing more. To respond to that method, I implement the respond method, as again in the Cowboy class, which receives the message and the question object. I instantiate a response object, pass in the message, pass in the original question, and push that on the chat array. So message is OpenStruct, response is derived from message. So simple. And to run that workflow, I simply create a chat stack. Then I pass in that chat stack into my Cowboy object. And I call respond. And in the end, I assert my chat. And if the chat is two cowboys, we're sitting at a campfire. Jim said, want some drink, Steve? Where is Steve? Who was already loaded that shit, responded, oh yes, and both were happy to the end of their days. So if this works, I finished the whole problem I wanted to solve. And the cool thing is that takes about 5 milliseconds to run the test. This is a fake, of course. But I don't have to start up the whole Rails stack and the whole framework in order to solve a very simple problem. And I didn't use any database at all. That was by using the PORO approach. So you might wonder, OK, this is nice, but in my application, I don't have cowboys, but users. And those users want to browse their chats maybe days later, so we need persistence. That's one of the main points of applications. So for the persistency, we got several approaches. I'm just showing a little bit of it by introducing DataMapper 2. So this is an upcoming object relational mapper. I think it's going to be available soon. And they completely changed the approach of using persistence in your model. So DataMapper allows you to include the resource module in your class, and then you define persistent fields in your objects. And this is usually mapped to this can be mapped to a database table. I mean, you know that from it's roughly like active record, but it's not bound to any specific database. It's not bound to any specific table layout. And the cool thing is we can also use that table or persistence declaration in a module. And so it's not bound to any of your PORO class at all. So you can have that Cowboy class as an OpenStruct, and you can have your database in a separate module. And then you extend your Cowboy or your message or whatever with that database declaration. And if you call methods from the database or fields from the database, the content or the values will come from the database table. So your object is kind of wrapped by DataMapper, and DataMapper will provide persistent fields from the database without you having to worry about all that stuff. That was a simple example. You can have like nested things and relations and whatever. But the main point is that we have the persistency and the domain logic separated. This is love in the Ruby community. So, my favorite topic to talk about, views. Let's say we have a sidebar in our application. Who's running a Rails app? What? Wow, this is awesome. Who's having sidebar elements or dashboards? Are you happy? Good. So let's say we have a sidebar, and in this sidebar we have two boxes of functionality, two parts. The top part of this sidebar is a list of all the recent messages of our chat, and the lower box is displaying the chat activity at the campfire. It doesn't make any sense at all, I know, but I'm here for showing concepts, not applications. So pretty simple. Usually this happens by having a sidebar partial, and then you call render sidebar in your controller view or in your layout. And this works fine as long as the sidebar is pretty simple. Here it is simple because we have two box diffs. One is the recent messages box, and we render the list of chat messages. And the second is calls a helper, the pie chart for the chat activity, and we put them in two different diffs, and that's it in the partial. So that makes this beautiful, magnificent sidebar. So now I want to have two different sidebars, not really different, just a little bit. So I want to have the top should display the recent messages, and the lower box should display the happiness indicator of our chat. Another stupid example, sorry. So we have two different sidebars right now. One is displaying the pie chart of the chat activity. One is displaying the chat happiness. And to make it even more difficult, I want to have the pie chart sidebar on 3 controllers, and I want to have the happiness sidebar in 1 controller. So we have two different sidebars for different contexts. Yeah? And usually this works by you put in some decider in your partial. Like if we are in the pie chart context, render the pie chart in the lower box. If we are not in this context, and render the happiness chart. So we're having logic in our view. Should we have logic in our view? Right answer. No answer is always the right answer. Let's have another look at this. So in order to, so I want to get rid of this decider logic. And in order to do that, I use a view component. This is a gem available for all Ruby developers out there on rubygems.org. It's called cells. And the view component, what is that? So the view component works as follows. Instead of calling render partial, I call render cell. And I pass in some values like which cell to render, the sidebar. I pass in show, so I basically tell render the sidebar cell with the show action. And I also pass in the chat object. So if you look at this sidebar cell, it's a separate class. It's very simple, and you can compare it to an action controller without all the action noise. So we have an action called show. This action receives arguments. In this case, the chat object. So I assign the chat object to an instance variable and call render in that very action. Render itself will render a partial. We call it a view in cells, which resides under app cells sidebar show.html.whatever. And this partial looks exactly the same as the partial we just had. So yeah, and we still got the decider in that partial. I still want to get rid of that, but the first step was to encapsulate this partial thing into a cell. Now, if we look at this, if you look at the two sidebars we want to render or create, we can see that the top part is the same in both of those sidebars, and the lower part is different. So what about if we override our view somehow? If we apply object-oriented techniques to our view. So if you have a class and you have some behavior, like we have a message class and we have the toString method, and it's calling cell upper, so it's uppering the string and then prints out the message, and we want to change that self.upper part in a class. What do? You extract this part you want to override to the format method or whatever, and call this method in the original piece of code. And then you derive a new class and override the parts you want to override. OK? So this is a basic principle you guys are using every day, I hope. And now let's apply this approach to the view with view inheritance. Do you guys know view inheritance from Rails 3.0? It's they got a view inheritance in Rails, but it is a little bit clumsy. By the way, they stole it from the cells gem. Here's how it works in Rails. So if I call render partial item in the mommy controller, the mommy controller will look for views/mommy/item partial. If I derive a controller from the mommy controller called child controller, and I call render partial item, the controller will look in views child item, and if this view is not found, it will look in the superclass views/mommy/item. This is how view inheritance is usually working. So if there is if the view is missing in the class, it looks in the superclasses in the ancestors directories. So in order to use that in cells, we take the part we want to override, which is this decider part in the bottom, and we replace it by introducing a new view. So in the class, we introduce a new method. In the cell, we introduce a new view. The view is called lower box. So I call render view lower box. That's the API of cells. We don't have partials and views. We just have views. Everything is a view. And the lower box in the sidebar cell just contains the pie chart. Okay? It's just the one div containing the pie chart rendering. Sidebar/lower box. The next step is I create a new cell. I call it funny sidebar cell and derive it from the sidebar cell. And I introduce a new view, the lower box view, put it in the app cells funny sidebar views folder. It's also called lower box, and I just call the rendering for the happiness chart. And this is all I need to override a specific part in the view without having deciders. So in the three controllers where I want to have that activity chart in my sidebar, I call render cell sidebar. And this will print out or render this beautiful sidebar with the pie chart. If I want to have the happiness sidebar, I call render cell funny sidebar. And this will inherit all the logic and all the views from the original sidebar, but it will replace the lower box with this beautiful guy from Ukraine and this % indicator. And all this works just by deriving from a cell and overriding the view. So this is a very interesting technique to be used in your view, and you can improve your view architecture by introducing object-oriented cells. I wouldn't use it in every occasion. So there is projects, they don't use partials at all. They use cells everywhere. But as soon as your view gets too complex and you have too many deciders and stuff, and we also got nice solutions for caching and stuff. So as soon as it gets too complex, you might think about changing your architecture from Rails partials into cells. That's beautiful. You can find this on GitHub. I don't put URLs into my talks because you guys are supposed to watch me talking and not browsing your laptop. Oh, something I want to really know. Is it a law in Australia when you ride you call it Pushbike? Is it a law to wear a helmet? Yes. Because I'm staying with a friend, and he would give me his Pushbike to travel around, and I just started riding, and I forgot the helmet, and then after like 5 minutes, I saw like 50 people, and they were all wearing helmet, and I got scared, so I turned it back and got this helmet. So okay, so I'm not looking stupid because I want to look stupid. I look stupid because I need to. All right. Interesting. Is that when did that law came up? Like, were there lots of 10 years ago, and lots of killing accidents, or? I think this is a good thing. What's next? Controllers. So usually a Rails controller is a monster. It's working pretty well for smaller applications, but sometimes they really get scary, I would say. So usually a controller works like you have an action representing a page or an API endpoint, and then you aggregate data. I do chat.find, whatever, and then you assign the data to some instance variable, or you somehow pass this data to your views. And then you render. That's how a controller is supposed to work in an HTTP environment. An interesting gem I found is Objectify. Again, I wouldn't use it in every occasion, but it's very interesting since it splits up your controller logic into separate classes. Again, classes for like following the single responsibility principle. So if I use Objectify, I hook into a route. So I'm not going into the details how that works. I just tell Objectify, you're responsible for the slash messages URL. And then I need to provide 3 classes instead of 1 controller. The first class is a policy class in which is responsible for checking if this URL call is valid or not. So it's just a single class with a single responsibility. The next class I need is the actual service class, it's called service, which does the logic of aggregating the data, finding the chat object, or finding the chat messages, or whatever. And the third is a responder. That's how they call the rendering. So in this service class, the data is passed from one instance to the next instance, which is done by Objectify. I don't have a clue how this works. And the responder is responsible for rendering. So we have this 4 steps, or maybe 3 steps, split into 3 separate classes. And this is pretty helpful if your controllers get too big. So if you have too many before filters and too much logic in your actions, and the rendering is doing scary stuff, it's an interesting option to check out this Objectify gem. I haven't used it myself. I would love to show you a real example, but if you're interested, it's at BitLove Objectify on GitHub, the Facebook for nerds. Who is not on GitHub? Who? Wow. And who's not on Facebook? Wow, cool. And who's not on Twitter? 1 or 3? Wow, 4. Why not? I tell you why, because it's completely useless. Prejudice. Prejudice everywhere. So let's see some patterns how we can implement API endpoints in Rails controllers. So in our example, the campfire example, we had I might need some API for listing all the messages from the chat or message details, whatever, and maybe I want to send messages, so I need some API to allow that because I want to have my campfire application on my iPhone. I'm not owning an iPhone, by the way. So usually APIs, they all work the same. We have documents that are rendered by API endpoints or by clients, and then these documents are pushed into services. So either I ask for some message, and I get a JSON document, and I read it, and I parse it, and then I push it back to the respective URL to change the state of my application. This is how every API works in here. And Rails gives us a couple of different techniques to do that. So one is SJSON, and for rendering, so we can render documents from models. And you have to include a big configuration hash. And when this started, the SJSON approach, people were amazed. And then they found out it's end up in a big 5 or 10 level deep configuration hash. Hash-driven development was one of the favorite words I read about it. So they came up with Active Model Serializer, which is a very nice approach. It's an object-oriented style of rendering, but it's only for rendering models. And then we have, for the parsing part of our application, we have the params hash in Rails. I don't know if you're aware, but params is automatically parsing incoming documents, whether it's XML or JSON, and you get the parsed data in params, in the params hash, and you can walk down the hash. And then they came up with strong parameters. I'm talking about him. And strong parameters is like an access control for the automatically parsed params hash, which is going to end up like SJSON in a big 5-level deep configuration hash, maybe 6-level. And the problem I see here is that rendering and parsing, we are rendering and parsing the same documents. The document has the same semantic, but the rendering and parsing happens in 2 different places. So we spread our knowledge about this document, about our API semantics, over the entire framework. And this is something I would like to have in one place. So somebody smart, clever, dynamic, German, came up with the representer pattern. So here's how this works. So if I call my API endpoint messages/1, I get back a JSON, a very simple JSON document. I'm giving very simple examples. So it's just a JSON hash with 2 properties of that message object, okay? And here's how a representer would implement this API endpoint. So I'm defining my document in a module. And by including the raw representer JSON module, I get all the, I don't say magic because I hate magic, I get all the functionality into that module. And so I use the property class method to define the fields I want to have in my document. And to render that document, I take a message object instance, I call extend, I push in or mix in that message representer into that instance. And then this will give me 2 JSON, but not 2 JSON from Rails, 2 JSON from me. And of course, this will exactly create the JSON document I want to have. And the cool thing about representers is it's not only rendering, it is also parsing. So we can use the same representer, the same module. I create a new message object, I extend it with the message representer, and I get from JSON, not from Rails, from me. And then from JSON accepts the JSON document I want to parse. And when I call message.content, the content is from that parsed document. So representers are bidirectional. They aggregate all the knowledge about documents and for my API in one place. And they are, right now they are mixed into the model, but there is a new branch where the representer wraps the model, so your model is not touched at all when you render or parse. And the cool thing about representers is there's no magic. They just, when we parse an incoming document, we parse out the fields you defined, and then the representer calls the accessors on that model instance. So it just calls content equals, created at equals, and it's up to the model to set these values. And the same with rendering. Instead of magically finding out what to render, it just calls content and created at. And it's the object's, the model's responsibility to provide that data. So representers are pretty dumb. And that's a good thing. Not for people. So representers can also have nested settings, like you can have, I don't know, what's the example, like messages can contain cowboys, and cowboys can contain chats and whatever. So you can have nesting, and you can have collections. And you can also have different formats. So if I don't want to have JSON, if I want to have XML, representers come with XML and YAML endpoints. So instead of including the JSON, I call XML module, and I get 2 XML, and I get, wow, XML instead of JSON. So it's pretty simple to switch your media format if you decide to switch from JSON to XML, which I would not recommend. Anyway, if you want to do it, it works. Who's doing XML APIs? Oh, okay. Yeah, I don't have a problem with XML, but I gave a talk about APIs like 2 years ago, and I was doing the examples with XML, not with JSON. And I got like flooded with tweets like, you asshole, you're doing XML, why don't you do JSON? So here's JSON. So, and another cool thing about the representer approach is that we have extensions. Here's an example, David. What if we want to do hypermedia links and hypermedia paths in our API? So I want to embed links to other API endpoints in my documents. A lot of people do that. It makes your client more decoupled from the backend, and so on and so on and so on. David Heinemeyer Hansen does not like it. I do. So I include the raw represented JSON Hall document. The JSON Hall is a new upcoming media format which defines semantics about representations for objects, and also it defines semantics for hypermedia linking. You'll see when you see the document, you'll know what I'm talking about. So what JSON Hall gives me, for example, is an additional method called link. So I can define links, and then I pass in the link meaning. That's the self link, for example. And then I can use, in this example, I use a Rails URL helper to include that URL as the self link. And when I call to JSON, the JSON Hall module will take care of rendering and parsing this object into the JSON Hall standard format. So the JSON Hall standard defines that links must be in a separate key called _links, and links have a special format like the self, colon, and then you pass in the URL and stuff like that. And I don't have to take care about all that stuff. That's all done by the JSON Hall module. So I don't have to worry about generating a valid document. That's done by this object-oriented model. And the cool thing is I can also change, if I decide to change from JSON Hall or from JSON to there's another media format called JSON Collection. And I just include this representer in the representer, this model in the representer. And it gives me a completely new DSL, which is pretty close to the original DSL of representers. So I can define specific properties for that JSON collection format. So it doesn't matter what I'm doing right here, like the version call and the href call. But what I want to show you is that it's pretty simple to change your API into a media format that is already defined, like JSON collection. And the representer takes care of all the rendering and parsing, so you don't have to worry about that. And it works, again, both ways. If I call to JSON, it's going to be rendered following the standard of JSON collection. It also works with parsing. That's cool. So I can parse a JSON collection document, and I can access attributes without having to fiddle through a 5-level or 6-level deep hash. This stuff is available on GitHub, again. And so these were some quick examples, very simple. I hope it wasn't too simple, because you guys are smart, I know. So I was trying to show you how to separate domain from persistence using the PORO approach, maybe with DataMapper, maybe with some other genius upcoming gem you guys are going to write. Then we had view inheritance, or encapsulating parts of your view with cells. We had the Objectify gem to split up your controller into separate classes. And we had the ROR, or the representer gem, to have object-oriented documents for your APIs. And so these were just examples. So it's up to you to use that stuff in your application. The cool thing about Rails is it's not anymore forcing us to use all the conventional approaches they provide. So you can change your, let's say, the API code step by step. You can introduce representers where you need them. You can use Rails where you want. So it's pretty easy to change your code into more object-oriented code. And it is needless to say that you shouldn't be scared of using more classes. Nothing will happen to you. Your code will get better. Okay, so don't fear the glass. And thank you.